How's it going, everyone? Welcome, Elier Gonzalez here. And today, let's take a look at the React course taught by Josh Comeo. To understand now is when it comes to build small projects, for example, like Wordly, that it gives you 6 attempts to guess a 5-character long word, okay? So to create any small, even small application, I started to figuring out what is the nature of how to even apply to, how to create this. So this is quite similar to the algorithm. When you need to first define is the input and the output, and then now systematically create now as a naive approach, defining all of these series of steps. Also understand the what is the trade-off of this approach and how you can do better with it. I do think that this particular process is it's a straightforward, has shown that works until something else actually now tell you that give you a more straightforward way to understand requirements and how to work with that. So pretty much like you're building a machine here, which is exactly what we're doing here. This, and I just want to bring this up because there is a concept here, this computational thinking in higher education. There are some other or known as CT, okay, which is defining is a systematic way to solve a systematic way to think critically about a problem and now create a solution from it, right? There are also several papers as well. I do think that this particular approach, when it comes to generate outcomes, is quite straightforward. All right. So what you are doing with this computational thinking is not only something that is abstract, as when you are working with something, when you are trying to understand a problem of this, right? This computational thinking that has been shown that has tremendous application and so far works when it comes to solve problems. But first you need to understand the problem that you're trying to solve. So yeah, I do think this is a very interesting so there are several papers here, and how now they're going to implement is this particular thinking into curricula from K-12, right? Where I do think that is again, all of these are attempts to be functional first with yourself as a human, and then with others, and then as a society, and then as with the family, and then as a collective, and as your party, and as a state, nation, or even the world. Okay. So in any case, this is what we're going to do in this particular application that we're gonna build, known as a known as Wordly. All right, it makes a lot of sense to start is with the input. All right, find a way to capture that input, and then what will be the expected output. It doesn't have to be perfect, straightforward, right? But it must be is an output that is ready to be that works. That's what expected. Okay, and then is when you're now going to define is the logic around it to actually fine tuning that process. So that's very interesting, by the way. So let's take a look at here.
So far in the course, we've done quite a few exercises and challenges, but they've all been pretty self-contained. They've kind of fit neatly into the playground component that we use in the course platform. This project is a little bit different. It's quite a bit more in-depth, and so because of that, I think it makes more sense for us to do it on our local machines, downloading the code and treating it like any other project that you might work on. Of course, this introduces some additional challenges, and there are some very important things that I want to make sure that you know before you get started that'll hopefully make the whole experience go much more smoothly. The first thing to note, right, so you download the code, you have it open in VS Code. The README is your home base for this and all the projects that we're going to work on in this course. The README essentially breaks the project into smaller chunks called exercises, and hopefully it'll make the whole thing much less daunting because, building a Wordle clone is a significant thing, and if I just told you to do it without giving you any guidance, that might be a really, really difficult and unreasonable challenge. So the README essentially breaks it into exercises and gives you a few tips and pointers. And it also is very clear about what you have to do in each one to be considered succeeding in that exercise, to have completed the exercise. If you open any Markdown file in an editor like VS Code, it opens it in editor mode so that you can, make changes to it. That's actually not super useful for us, and really it would be better to view the Markdown file as Markdown. You can do that in VS Code by opening the command palette. You do that with Command-Shift-P on Mac or Control-Shift-P on Windows or Linux. Type the word Markdown and select the Open Preview option. And, this will actually make headings look bigger. The big thing that it does, the reason that I think this is so important, is that it will actually render images. So instead of just seeing the Markdown format for an image, you actually see the image itself, which, for all these exercises, I'm going to show you little previews of what you're expected to build, and seeing the image is obviously much more helpful than just reading the alt text. As you go through the README, you'll see that you have these HTML snippets that kind of depict what the markup for this exercise should look like. And in fact, even more than that, if you go into the docs folder, you'll see that you have an HTML file called end result. And this file includes all of the markup that you're expected to have at the end of the final exercise. So it's the final HTML code that I kind of exported from the app with a bunch of data kind of filled in haphazardly to show you an example of what it should look like. Now, when you see this, you might think that this is maybe too much of a hint or removes the challenge. I can assure you that is not the case, because coming up with the markup is actually more of like an HTML CSS thing. And I really want us to focus on the React and JavaScript parts of this challenge. And it is not simple trying to figure out how to get the right markup with all the right state and the right calculations just with React. It also means that we get to worry about styling a lot less, because as long as you apply the right HTML elements with the right classes, well, you'll notice in SRC we have these styles.css, and that means that all of the styling will kind of just happen automagically, as long as you follow the markup that is prescribed in the README and in this end result.html. Okay, one more thing. If you go into the SRC components folder, you will see that I've used a file structure where every component has its own folder, along with the code for that component itself, as well as an index.js. This structure can be kind of tedious in terms of when you need to create a new component, there's a lot of boilerplate, right? The good news is that you don't actually have to do this work. And if you look at the package JSON, you'll notice that we have this new component script that is not typically a part of Create React App projects. What this does is it essentially creates a new component in the style that already exists in this project. So you can open the terminal and type npm run new component and then the name of the component. So if I have a hello world component, you get this happy little output that confirms it was built. And if you look in the project, well, now we have a new file that matches all of those conventions. So it has the file, the folder, and the index. Essentially just an easy way to give you the files that you need so you don't have to worry about any of this stuff. All right. I think that's everything I had to say. If anything remains unclear or you have questions about how to get started or you're getting stuck on something, please come to the Discord community, ask the question. I and others will be happy to help you on your quest. So have some fun with it.
All right. Delightful file folder. As shown in the video above, each component is giving it its own directory with a peculiar structure. You might be wondering why I have structured things this way. It seems pretty over-engineering, doesn't it? Over the years, I have experience with a lot of different file folder convention, and this is the best structure I have found. It solves a number of small but annoying problems. I'm going into detail about this structure in my blog post, The Life for React File Directory, and I suggest you to give it a read if you're curious about. This pattern is also much easier to follow with the new component package. It has been installed automatically for this project. To install in other projects, you can follow the GitHub as it is. So you have pushed the component that exactly. New component, simple customizable utility for adding new React components to your project. Okay. Okay. Co-founder and CEO at Inline, the chat company. Previously founder of Noor, a virtual office and chat app for remote teams, where I created a Rust WebRTC client stack instead of using libWebRTC, made there, used by 70k people, including from Shopify, Apple, Amazon, and Google. There, local times for your friends, teammates, or family in menu bar. Oh, that's interesting. That's very interesting. Oh, that's useful as well. Chat that is in from 2010. We're building a native high-quality messaging app for teams who craft the best. Get to the waiting list. Okay, coming soon in early access from macOS, iOS, written in Swift, and for the web. Co-host GraphQL Europe 2018. Alexis Stogel. The hell is this? Oh, the website. The website has been taken off. Yeah, the website has been taken off. The website has been taken off. GraphQL Europe. They didn't they didn't update that. And now people just bought that. Ooh. The hell is this? Citus Toto Online. Gambling. Alright. Pioneer Alumni. Pioneer App. Tallinn, Estonia. It's because in Estonia people do alright. They're a virtual office for remote teams. There.team. Okay.
Hey, great to be super happy to be presenting to you this. We are building there, which is presence for remote teams. Little notification, which is no awkward moment to join, to end, and no passing links to join.
Good. Public appearance. Interview with Crab Nebula. Interview with Mo Rahabi, co-founder of CEO of Noor. Interesting. Ignore.
Hello everyone, thank you everyone for coming to our YouTube channel. I am Eleftheria from Crab Nebula, and today I have the pleasure to have with me Mo. Mo, would you like to introduce yourself and share a little bit about your background?
Hey, nice to meet you, Eleftheria. It's good to be on the channel. And I'm Mo. I'm co-founder and CEO of a product called Noor.
Okay. Tauri. Le Università Malta. Exactly, it's heavily in Europe. Heavily in Europe. Okay, how he start? What is Node and its best part? What package and technology did he utilize to build it? Challenge and the dev tool. Plans and goals for the future Node. Mm-hmm. Eleftheria. Alright, alright. Presenting to this trainer.
Hey, great to be super happy to be presenting to you, Des. We are building there.
Okay. Lightning Talk at Web DLDN in 2017. Alright. So giving now to all of his people. Alright. And the Twitter. Exactly, but at the end of the day, it's just simple. It's simple. Simple stuff, bro. Simple stuff. Simple stuff. Is that. You know what I mean? Is that. Alright. An inline chat, and there is also a there.pm. And yeah, you get this. That's good. And the using also is blue sky. Oh, that's good. Okay. Good, good. He also is also one of the contributor here. CLI utility for quickly creating new React component. If we look at the here bump up version, yeah, there are 9 issues here. I'd be awesome if new component could include base style component, CSS model. Okay, but that was in 2017. God damn. All right. Good. Good. So this is the CLI here. As a way to generate is now this by default. len and the value in JSON. And here they are using is on the index, they are using is a program, which is the commander that allow you to have access to the console. Dot version arguments component name and the option whether it is len language, which language to use, default JavaScript, and this, and then configure the language. You have another option whether it's a dir and dir path for so, and then you're going to parse all of this with the values that you are receiving here. And after you process that, then you're going to identify is which one of them, right? So for example, you say, hey, the component name here, and then the options, which is now an array, file extension and index extension, the option.len, template path. So you can extract this information out of this. And once that is done, you can say, hey, log intro, name the component, dir component len, check if component name is provided with this. If the component name does not exist, log error and exit the process. However, if it exists, so let's create parent directory if it's necessary, which I do think that might be a utility function from the helper. Okay, option.dir, check to see if this component has already been created. Exactly. And then start by creating the directory that our component live. Make dir promise. So once you already create this with the component there, which is the name, all right. So once you create now this as the option, and once that is done, well, I'm going to read the file and pass now the template path, which is what they define here as this, the template.option.len, okay, which is inspecting into the templates. You like a look at this, you say, hey, this will be now the template for TypeScript, now for JavaScript, and oh no, this is for both of things are for, okay, both of them are for that, which at the end of the day it is the same. The only thing that changed is the name of the extension. And as the index goes on, right, so this is one of the great thing of the chaining flow control, is the ability to know is define the flow, the asynchronous flow control in that way, right? So hey, once this is done, so now you have to return is a new promise from this that it will have now is the template, and this template it's a hey, login completion directory created is gonna return now the template here, all right, and then once you now get the template, you're going to replace that with the component name, right, as a string with the name of the component, and then now provides the proper format, write file promisey with this, like so, and then once you get the template, hey, component build on save to disk, which already write that, is gonna return now the template, and we also need the index file which allow easy importing, and then index files build and save to disk, and there you got it. So log conclusion, and on any error you're gonna catch dot error as it is. So this particularly file here that was defined here, right, is just to illustrate that how you can define is a control, is a flow control, is a sequence of async promise of things, of computation that's gonna be resolved at some point in time. And when that done, okay, so now is continue this flow of execution. So yeah, that I do think that's quite interesting. All right, I go into detail about this structure in my blog post, the delightful React file directory structure, and there you got it. Good. So because it already have that, and I don't know, for example here the widget, the helpers, the contents, and the index. Alright, so I'll explain everything in depth, but I thought it would be fun to let you take a self-guide tour first. Here is an interactive file explorer. Feel free to poke and see how things are structured, so you can now understand, modify that. But see is this. So for example, use custom hooks. Okay, so when you're going to define your components, because there is a lot of layers around it, the custom hook, the widget child if it has, the widget component as it is, the widget parent, or the widget helpers, all right, and the widget constant. Whether you define the constant, color theme, breakpoints, public keys, and other app-wide constants, exactly, followed by the utility functions like the one you get from library like Lodash. You define your hooks, global hooks, all right, hooks that calculate the bounding box for a specific HTML, full source show later in this block, and then the helper, the animation helpers, and the auth helpers, function related to authentication and authorization. You have the header, you have the app, and then you have now is the index here. Alright, so the file in this demo are JavaScript, but I use the same structure in my TypeScript project and it works just well. My priority, let's start by talking about my priority, the thing I have optimized for. First, I want to make it easy to import components, and I want to be able to write this. Import button from button, or using webpack aliases. We'll talk about this further down. Import button from add components button. Next, when I'm working in my ID, I don't want to be flooded with index.js files. I have worked in project where the top bar looked like this. Oh, okay. To be fair, most editors will now include the parent directory when multiple index files are open at once. My goal is to have nice, clean components file name like this. Finally, in terms of organization, I want things to be organized by function, not by feature. I want a components directory, a hooks directory, a helpers directory, and so on and so forth. Sometimes the complex component will have a bunch of associated files. This includes hook components, small component used exclusively by the main component, helper function, custom hooks, and constants or data shared between the component and its associated files. As a real example, let's talk about the file viewer component, using this block for the interactive file explorer demo. Here are files created specifically for this component: file viewer, which is the main component; the file content, which is a subcomponent, the component that renders the content of a file with syntax highlighted; the list of files and directories that can be explored; directory, the collapsible directory to be used in the sidebar; file.js, an individual file to be used in the sidebar; file viewer.helper.js, helper function to traverse the tree and help manage and expanding collapsing functionality. Ideally, all of these files should be tucked away out of sight. The only need when I'm working on the file viewer component, and so I should only see them when I'm working on file viewer. One component per file. For a while, a popular ESLint rule warned against defining more than one component per file. I think that's a silly rule. Files can contain as many components as you like. That said, I do generally find myself pulling non-trivial components into their own files. Once I have the basic functionality working, it helps keep things organized and make it very clear which import, style, whatever are you used by which component. The implementations, and then you have the components. This is part of his way of doing things. This is essential a redirection. When we try to import the file, the bundler will forward this and hold the actual code. Again, this is your take on building that. The anti-barrel method, the barrel file debacle. Please stop using barrel files. Speeding up the JavaScript ecosystem, the barrel file debacle. Many projects are literal with files that just re-export other files. These are called barrel files. Are one of the key reasons why JavaScript tooling is slow in bigger projects. Post CSS, model resolution, linting with ESLint, draft emoji, polyfill gone, the barrel file debacle, dealt with CSS, server-side GX, isolated declaration, ROS. So let's imagine you're working on exactly, but it's this. Gathering more information, anatomy of a barrel file. Everything is not fine. Ask yourself, what's quicker, having to load 30K file or just probably 10? Probably only loading 10 file is faster. It is a common misconception among JavaScript developers that model will only be loaded when needed. This is not true because doing so will break code reliant on globals or model execution orders. If the engine wouldn't load the first A import, then the code will expect log undefined instead of 1, 2, 3. Global this.foo from a.js. Global this.foo should log 1, 2, 3. And when you import that, are they hosted? If the engine will load the first A import, then the code will unexpectedly log undefined instead of 1, 2, 3. It gets worse. Effect of barrel files on performance. Get rid of barrel files. The anti-barrel movement. Please stop using barrel. Barrel files. and Dominic from Vienna. Time stack query and time stack router. Okay. The anti-barrel movement. The main argument against barrel is that it slows down the bundler, leading to longer build hot reload times. Dominic Post also referenced an issue with circular dependency, but I have never had this issue because I wouldn't structure my input the way he does in his example. Wherever we import one of these components, the bundle first has to load the index and then load the reference file, fileviewer.js. It is twice as much work for the bundler. But how much time is the bundle actually spending resolving our barrel? Using this blog as an example, my entire project has 180 barrel files out of the 1200 total TypeScript and JavaScript files. To put that in perspective, when I compile a single blog post, the bundle have to parse more than 10,000 modules. Most of these are from third-party dependencies that live in Node.js. The barrel files are dropped in the bucket. We'll revisit this topic in the trade-off section below, but I wanted to mention this early since I get lots of questions about it. This code is real. It is provided here as an example, but feel free to copy the hooks you are interested in here. Use bounding box to get that element and get the current bound client here. Okay. Use bounding box. Use effect on change. Use has mount. Use is on a screen. Use throttle state. Use throttle state. Use is on screen with the observer with the throttle, and use window dimension. And use worker to create now a new worker if that doesn't exist. Create now a new worker constructor, and connect that to the worker via the use effect. Naming convention, YOLO policies. Use Bob instead of use Bob. I'll be honest, I don't have a good reason to make this decision. I just like the way it looks. Helpers and utils. Trade-off. Battlefield. As I mentioned about this pattern, use Battlefield. Each main component directory have an index.js that does nothing except to re-export other stuff from its sibling files. In theory, this is a problem because it means the bundler have to do a lot of more work, but I don't believe it is something that most of us have to worry about. This blog has about 1200 this blog has about 1200 TS and JavaScript files, and 50% of them are Battlefield. My node models directory, by contrast, has 5,000 TypeScript and JavaScript files. So really, the bundle will spend most of its time dealing with third-party dependency. Less than 1% of the model that the bundler encounter will be barrel field that I have created. If you're working on an npm package, it is probably a good idea to avoid barrel fields, especially if it is a library like Lodash with hundreds of individual models. But I don't really think it is a significant issue if you're building web application, unless that application has tens of thousands of files and millions of lines of code. At sort of scale, I can imagine it makes a tangible difference. More boilerplate. Whenever I want to create a component, I need to generate is the new directory, the new file, and the index forwarder. That's a lot of work to do up front. Fortunately, I don't have to do anything manually. A new component npm package will allow me to do that, which is create the directory, create the component, and the export file. Issues with app router. As I shared in how to build my blog, I recently migrated this blog to Next new app router. Unfortunately, when I use my new component package as is, I get an error. Syntax error. The name default is exported multiple times. This is because my var field has the following structure. Essentially, the bundler is upset because everything export everything, including the file, so it means exported twice. When I omit the second import, however, I get a different error bill. Type error. Model component file index has no default export. Frustrating. The only solution I have found is to remove the wildcard import to this. This is as nice since it means nothing else will be exported. Sometimes I also wanted to use name export as with this approach, and I had to remember to add them manually. I haven't had a bandwidth to look at this. If you like to use my new component package like with the next app router, suggesting fork it and remove this line from code. And remove this line of code. Organizing by function. In general, there are two broad ways to organize things: by functions or by features. It is an example of how structure go by features. You got all of this: the base, the search, and the users, right? There are things I really like about this. It makes it possible to separate low-level reusable component library type components from high-level template style. But here's the problem: real life isn't nicely segmented like this, and categorization is actually really hard. I have worked with few projects that took this sort of a structure, and every time there has been a few significant sources of friction. Every time you create a component, you have to decide where the component belongs. If we want to create a component to search for a specific user, is that part of the search concern of the user concern? Often the boundaries are blurry, and different developers will make different decisions around what should go there. When I started work on new features, I have to find the files, and then find might ignore that the where I expected them to be. Every developer on the project will have their own conceptual model for what should go, where I'll need to spend time acclimating to their view. And then there is a really big issue: refactoring. Products are always evolving and changing, and the boundary we draw around features today might not make sense tomorrow. When the product change, it will require a ton of work to move and rename all of the file, to recategorize everything so that it's in harmony with the net version of the product. Realistically, that work won't actually get done. It is too much trouble. The team is already working on stuff, and they have a bunch of half-finished PR where they are editing files that will no longer exist. If we move all of the files around, it is possible to manage this conflict, but it's a big pain. And so the distance between product features and code features will drift further and further apart. Eventually the feature in the code base will be conceptually organized around a product that no longer exists. And so everyone will just have to memorize where everything goes. Instead of being intuitive, the boundaries become totally arbitrary at the best and misleading as well. To be fair, it is possible to avoid this worst case scenario, but there is a lot of extra work for relatively little benefit in my opinion. But isn't the alternative too chaotic? It is not uncommon for larger projects to have thousands of React components. If you follow my function-based approach, it'll mean that you have an enormous function-based approach. You will have an enormous set of unorganized components sitting side by side in source component. This might sound like a big deal, but honestly, I feel like it is some small price to price. At least you know exactly where to look. You don't have to hunt around through dozens of features and find the file you are. And it takes 0 seconds to figure out where the place here. Webpack aliases. This is the file viewer, file helper, file content. Okay. And organized by function. You might have an idea here, a case here. You might have a case here, sir. I'll be right back. And we're back. Okay, so here, Josh Komewa make a blog entry describing is why he actually why he organized stuff the way it does for this small project, right? The Wordly. And it turns out that based on his experience and his own flavor, he now creates the folder, so the component name folder, as well as things that are relevant to that component, aka that is the name of the component itself, some constant specific for this component, as well as the custom hook for this component, some helper functions, and the entry point of this component that is going to help all of these files in one single place. So the trade-off of doing that, okay, as he mentioned here, the trade-off that is there are now is, so his blog has about 1,200 TypeScript and JavaScript files, and 50% of them are barrel files. So his node model directory, by contrast, has 50,000 K TypeScript and JavaScript files. So really, the bundle will spend most of its time dealing with third-party dependency. Less than 1% of the models that the bundler encounter will be barrel files that I have created. If you're working on an npm package, it is probably a good idea to avoid barrel file, especially if it is a library like Lodash with hundreds of individual models. But I don't really think it is significant a significant issue if you're building web applications. Unless that application has tens of thousands of files or millions of lines of code, at that sort of scale, I can imagine it is making a tangible difference, right? But here is the antiviral movement. And now I started to understand is this kind of stuff. Marvin.dev, which is on here, right? Part of the Preact team here. So good. And there is another from Hugo. All that is using is take a Dodo's block. From okay, and a currently maintainer of the 10 stack query and 10 stack router. Okay. The using is, I'm assuming, is Next.js for this. Oh no, only Gatsby to do so. Okay. Ethical ads and so on and so forth. Hi, I'm Dominic from Vienna, and he's now currently maintaining of 10 stack query and 10 stack router. Okay. Okay. Interesting. Interesting. Okay. Context inheritance in 10 tag. Okay. Deriving client state from server state. The useless use callback. No memo, no perf games. Effect events. I use callback ref as per radix. State is meant to be reactive and trigger a re-render. Okay, so this guy I actually have this, right? Concurring optimistic updates in React Query. Recreating server logic on the client. There is a lot of things here. Concurring optimistic updates in React Query. Okay, practical React Query. Create React Query data transformation in all of this. Using WebSocket with React Query. Effective React Query keys. Leveraging the query function context, placeholders, and initial data in React Query. React Query as a state manager. And error handling. Mastering mutations. So okay, it's defining is all of the things that now React Query is capable of. Concurring optimistic updates in React Query. Recreating server logic on the client. I have already written a bit of 12 mastering mutation in React. But again, this goes beyond the scope of today's video. Beyond the scope of today's video. Okay. Okay. Because now it's solving is now other kind of problems, and I just want to mention is two things here. Please stop using barrel files. All right. Circular import. Good import from use tab state model. Bad. This both import from barrel file and development speed. In my opinion, barrels are made to group content of directory in your product application. Unless you add even stricter linked rules, there isn't anything that will force other developers to only import from the barrels. So you can't make certain model private with them. Where barrels are necessary is when you're writing a library. Libraries like 10-stack React Query need a single entry point that we can put into the main field of the package JSON. This is the public interface of what consumers can use. To me, this is the only place where a barrel makes sense. But if you're writing app code, you are just making your life harder by putting index.js file into arbitrary directory. So please stop using barrel files. Yeah, there is a movement around against that, right? Effects of barrel files on performance, and so on and so forth. So the effects of files on performance, it gets worse when you take tools like Test Runner in consideration. In the popular Jest test runner, each file is executing its own child process. In effect, this means that every single test file constructs the model graph from scratch and has to pay for that cost. If construction the model graph in a project takes 6 seconds and you have, let's say, only 100 test files, then you waste 10 minutes in total to repeatedly construct the model graph. No test or any other code is being run during that time. It is just the time the engine needs to prepare the source cores to run. Another area where barrel files gravely affect performance is any sort of import cycle linting rule. Typically, linters are run on a file by file basis, which means the cost of construction the model graph needs to be paid for every single file. It is not uncommon that this alone causes linting times to spiral off the control, and certainly linting takes a couple hours in a bigger project. So you can see loading fewer models is very much worth it. Let's apply this number to a project with 100 test files, where a test runner is used to span a new child process for each test file. Let's be generous here and say that our test runner can run 4 tests in parallel. So if you have now 500 models, aka JavaScript files or ES6 models, and each one of them is taking 0.15 seconds times 100, and if you divide that by 4, so you have now a 3.75 overheat. If you have 1000 models, 7 almost 8 seconds. If you have 10,000 models, it will have a minute to run your test in four parallel threads. 25,000 K models, like, okay, 7 minutes. If you have 50,000 models, it'll take about 20 minutes. Since this is a synthetic setup, there are low ball numbers. In real project, these numbers are likely worse. Battlefields are not good when it comes to tooling performance. So what to do? Having only a handful of battlefield in your code is usually fine, but it gets problematic when every single folder has one. It is unfortunately not rare occurrence in the JavaScript industry. So if you work on a project which use barrel files extensively, there is a free optimization you can apply that makes many tasks 60 to 80% faster. Get rid of the barrel fields. He is the author of Preact, right? Okay. And the other is the contributor of the React 10 stack. Okie dokie. Okie dokie. Okie dokie. Okie dokie, okie dokie, okie dokie. Okie dokie. En grandes proyectos. Mm-hmm. Y el otro es equipo Preact. Mm-hmm. 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 And the other is now how Next.js actually define those components, you know? Particularly in the file system conventions here. If they are using is now they're not in the 16, all right. The directive, use catch private, use catch remote, use client, and use server. Font form, image component, link component, script component, and file system conventions here. Forbidden instrumentation JS, instrumentation client JS, but especially on route groups here. And what is the convention here? Use case, organizing routes by theme, concerns, or features, and defining multiple route layouts. Opting specific route segment into sharing a layout while keeping others out. So exactly, here now they create is a file, a folder per page, okay? A folder per page. And when it comes to organize now components, okay, the React, the one of the member of Preact in the React query say avoid using barrel for that. Avoid using is the barrel here, especially the barrel entry point here, because as your application grows and grows and grows, and then it needs to fetch that data, okay, and then you somehow need to fetch that data, because this is the anti-barrel here. It say the main argument against barrel fill is that it slows down the bundler, leading to longer build and hot reload times. Dominic post also reference on issue with circular dependency, but I have never had this issue because I wouldn't structure my imports the way he does in his example. And please stop using the file barrels. But the main argument is that it slowed down the bundler, leading to longer build and hot reload times. Whenever we import one of these components, the bundler first has to load the index.js and then load the reference file viewer.js. It is twice as much work of the bundler. So the bundler needs to load is the index files, and then load all the reference here. So, but how much time is the bundler actually spending resolving our barrel fill? Using this blog as an example, my entire project has 800 barrel fills out of 1200 total TypeScript JavaScript files. To put that in perspective, when I compile a single post, the bundle will have to parse more than 10,000 models. Most of these are from third-party dependencies that live in Node.js model. The barrel fields are dropped in the bucket. And we'll revisit this topic here, but the idea of this, because this is the way how React traditionally organize application, right? So you have now your entry point, right? Exactly. So you have now your entry point like this. So you say, hey, export everything for file viewer, or do this. So this is part of the implementations. Interactive file explorer. So you have my priorities. Let's start by talking about my priorities. The things I have optimized for. First, I want to make it easy to import components. I want to be able to write this like this, okay? Using aliases to tell now the model bundler, hey, anytime that you are now providing is the hot model reload, for speed up the development process, I do want is to know you help me here with this aliases, right? To indicate now where I need to look. So from which place I'm going to look at it. This is part of the aliases, okay? And finally, in terms of organization, I want things to be organized by function, not by feature. I want a complete components directory, a hooks directory, a helpers directory, and so on. Sometimes a complex component will have a bunch of associated files, and these include subcomponents, smaller component used exclusively by the main components, so helper functions, custom hooks, and concepts or data shared between the component and its associated files. As a real example, let's talk about the file viewer component, using this blog post for the interactive file explorer demo. Here's are the files created specifically for this component. File viewer.js, the main component. File content.js, the component that renders the content of a file with the syntax highlighted. The sidebar, the list of files on the directory that can be explored, which is something that I don't think you have that here. The directory, the collapsible directory to be used in the sidebar, in file.js, an individual file to be used in the sidebar. In file viewer, helper.js. Our file content, the component that renders the content of a file with syntax highlighted. Ideally, all of these files should be tucked away out of sight. They're only needed when I'm looking for on the file viewer component and so on. I should only see them when I'm working on file viewer. So the thing here is this: one component per file. For a while, a popular ESLint rule warns against defining more than one component per file. I think that is a silly rule. Files and can contain as many components as you like. That said, I do generally find myself pulling non-trivial components into their own files once I have the basic functionality working. It helps keep things organized and make it very clear which import styles and whatever are used by which component. Again, but it's all about the implementation here. So here so Josh Gomula is using this folder structure to organize it as components, but it's based on that, right? You have now the directory.js, the file.js, the file content, the file Google helpers, the file viewer.js, index.js, and the sidebar. This is just to organize things by components. This is what the file viewer has. Okay. So most of these files are the ones mentioned early, and the files needed to be filed for the file viewer component. The exception is index.js. That's new. If we want it open, we see a bit curious. We'd say, hey, let me export everything from the file viewer. All right. Everything from the file viewer and export the default from file viewer. This is essentially a redirection. When we try to import this file, the bundle will forward to the file viewer JavaScript file, right? So you have to import that, and we'll pull the import from that file instead of the file viewer.js. Holds the actual code for these components. Why not keep the code in index.js directly? Well, then our editor will fill up with the index.js file, and I don't want that. Why have these files at all? It simplifies imports. Otherwise we have to drill into the components directly and select the files manually like this. So what we're doing is say, hey, I do want is to export whatever now file viewer has. Okay, whatever file viewer has in here. It's not mentioned this because this is another example, but if you take a look at the widget, okay, whatever have these widgets, I want to import and export that. In this case is the widget here. Okay, so forward all export. Exactly. So you are redirecting this. And for this particularly, I do want is to now export with the default. All right. So this will be now is the export, the default export component that is gonna be forward. Okay. So why have these files at all? It simplifies imports. Otherwise, we have to drill into the component directly and select the file manually like this. Exactly, you will have to import that from here. With our index.js forwarding, we can shorter it is just to this. Import file viewer from, well, the file viewer. Why does this work? Well, file viewer is a directory. Exactly, file viewer is a directory. And when we try to import a directory, the bundler will seek out an index file. Exactly. When we try to export is a folder, the bundler is going to look at an index file, the index.js or tx. This is a convention carryover from web servers. My website account will automatically try to load index.html so that the user doesn't have to write my website account index.js. All right. Pretty much is that. This is a convention carryover from web server. In fact, I think it helps to think this in terms of HTTP requests. When we import source component file viewer, the bundler will see that we are importing a directory and automatically load the index.js. The index.js does a metaphorically 301 redirect to source component file viewer.js. It may seem over engineering, but this structure ticks all of my boxes, and I love it. And it ticks all of its boxes. And it ticks all of its boxes when you only want is to export is that component. When you prioritize things for that, and you find inside of that component you find inside of the component several things that you need to, right? So whether it's the custom hooks or the constants or the utilities, helper functions. And there now is a movement, anti-barrel movement here, right? Which says that, hey, when the bundler is loading all of these components for web applications that might have only 100 or thousands of files, that might be not that detrimental. But when you started to have now 10,000 of files or 50k files, and each one of those components now follow this particular index, so exactly, so the model bundler, whether it is webpack or vite, is gonna take now time to go to that index and then import that model to have access to. So for small web applications, this particular pattern might works. But if you find yourself now writing is thousands of components, okay, you might see yourself in a trouble. Okay, which is this, right? And then you have circular imports. And the barrel file debacle. Many projects are literal with files that just re-export other files. Their so-called barrel files are one of the key reasons why JavaScript tooling is slow in bigger projects. Where he explains is this: hey, I'm going to export this, and to measure that, the console.time end. If you run the code again and you're surprised the measure, you insert show that it is blazing fast TM. You repeated the measure step, but this time insert the console.time statement in the main entry file of your project and run the code again, but no dice. The logged measuring just confirmed that your code itself is super fast. What's happening? Well, strap in. This is the story of devastating effect Battlefield have on your code. Gathering more information. The key piece of information we have obtained so far is that the runtime of the code isn't the issue. You are measuring it, and it was a fraction of the total time. This means we can assume, even though if we do something like this, right, if we execute this function, right, interesting my code, check out this. a curious one you are. The GitHub shall reveal the truth you seek. Oh lol. Oh, grab. And then it's using is this to redirect that. Okay. Interesting. I like simple and fast organization, Epic Games, and Preact. That makes a lot of made a lot of sense. Marvin Hagemeister. Okay, good. So if you have now this function here where you say, hey, here there is the import won't work. Of course, the import won't work. But if you do this, for example, this kind of code. Let me do this to see if this will work. Exactly. Cannot use import statement outside of a model. So here, because we are in this environment, we cannot use this. So no problem. Let's say you have this, right? And then you now run a function here, right? Or you just assign this to foo, right? And by the time I call my cool code, you're gonna see that, well, actually it's pretty fast, right? It's actually just to execute that, it takes 0.2 millisecond, constant time n. If we run that again, this time now reduces dramatically in milliseconds, because now things are catch. But the first time it executes that, it takes now 0.02 milliseconds. All right. So if you consider this for each file, right, that you're going to load, right, you got an idea. You remember hearing that some npm package pre-bundle their code for performance reasons. Maybe this could help here. You decide to test that theory and bundle your code with esbuild into a single file. You purposely disable any form of modification because you want your code to be as close as possible to the original source. Upon completion, you then run the bundle file to repeat the experiment, and voila, it finished in a blink of an eye. Out of curiosity, you measure the time it takes to run esbuild and run, then bundle time together, and notice that both of them combined are still quicker than running the original source code. What's going on? Then it hits you. The main thing a bundle does is flatten and merge the model graph. Flatten and merge the model graph. What was once composed 1,000 of files is merged into a single file. Exactly what a bundler does is to flatten and merge the model graph into one giant single file or into multiple ones, right? That can be sent over the cable at a reasonable weight, right? 20, 50, 100K. So it's merged into a single file thanks to esbuild. this will be a strong indicator that the size of your model graph is the true problem here. And barrel files are the main cause of that. Anatomy of a barrel file. You may import all of it. So look at this import. This gave rise to a pattern where every folder got its index.js file that merely re-export code from other files. Alright. In a way, this amortizes the manual picking work because one such file is in place and all the other code only needs to reference one import statement. The previously shown import statement can now be collapsed into a single line. If you have now a feature that contains all of these different features here. After a while, this pattern spread throughout the code base and every folder in your project has an index.js file. Cannot need, isn't it? Well, no. Everything is not fine. Is in such a setup, a model very likely import another barrel file, which pull in a bunch of other files, like this. So remember that the job of the bundler is to flatten and merge the model graph. So you have now all of this different, you have now all of this like in a tree, like data structure. You have all of these models that are my calling here, okay? This is per one file, per one index file, and the another, and the another. So the bundler will now is flattening is, so getting all of this into one single file and then merge that with another model and so on and so forth. It is a common, ask yourself, what's quicker, having to load 30K file or just 10? Probably only loading 10 files is faster. It is a common misconception among JavaScript developers that model will only be loaded when needed. And this is not true because doing so will break code relying on global or model execution order. It's common misconception among JavaScript developers that model will only be loaded when needed. And this is not true because doing so will break the code relying on global or model execution order. If the engine wouldn't load the first A import, then the code will unexpectedly lock undefined here. Instead of 1, 2, 3. Because because some of those models might rely on global, which is something that you shouldn't do that, or a model execution order. Effect of barrel files on performance. It gets worse when you take tools like test runner in consideration. In the popular Jest test runner, each test file is executing in its own child process. In effect, this means that every single test file constructs the model graph from scratch and has to pay for that cost. If constructing the model graph in a project takes 6 seconds, exactly, if constructing the model graph in a project takes 6 seconds, alright? So linking all of these different models and construct that model graph, let's say only 100 test file, then you waste 10 minutes in total to repeatedly construct the model graph. If constructing a model graph in a project takes 6 seconds, and let's say only 100 test files, then you waste 10 minutes in total. Why 10 minutes? It will be 600 seconds. Oh, yes. In total, to repeatedly construct a model graph, No test or any other code is being run during that time. It's just the time that the engine needs to prepare the source code so that it can be run. Another area where battlefields gravely affect performance in any sort of import cycle is linting rules. Typically, linters are run on a file by file basis, which means the cost of constructing the model graph needs to be paid for every single file. It is not uncommon that this alone causes linting times to spiral out of control, and certainly linting takes a couple hours in bigger projects. But it's because linters are run on a file basis. So if your linters okay, any sort of import cycle linting rules. So if your linters are run on a file by file basis, it means it's gonna construct the model graph. So the cost to build the model graph just only to know the engines, what then is the code that needs to be run. This only causes linting times to spiral out of control, and suddenly linting takes a couple hours in bigger projects. To get some raw numbers, I have generated a project with files importing each other to get better sense of the cost of construction the model graph. Every file is empty and contains no code other than import statement. Timing and measuring on my MacBook M1 Air 2020. As you can see, loading fewer models is very much worth it. Exactly, loading fewer models is very much worth it. Let's apply this number to a project with 100. This is if you have now number of models, 50k models, and time in second. It takes now, this is only import exactly, but for import files, with files importing each other. Let's apply this number to a project with 100 test files, where a test runner is used to span a new child process for each test file. And let's be generous here and say that our test runner can run 4 tests in parallel. 500 model, it takes now 3 seconds. So let's apply this number to a project with 100 test files. If you have now a project with 100 test files, where a test runner is used that spans a new child process for each test file, let's be generous here to say that our test runner can run 4 tests in parallel, which since this is a synthetic setup, and here we have 500 models, okay, 500 modeling each one of, okay, and those takes now, so 100 models take 0.50 seconds. Uh, 0.50 seconds to be processed. For 10,000 models, it takes now, which is, okay, it's because you're including is 100 test files here. Since this is a synthetic setup, there are low ball numbers. In a real project, these numbers are likely worse. Barred files are no good when it comes to tooling performance. Having only a handful of barred number files in your code is usually fine, but it gets problematic when every single folder has one. It is unfortunately not a rare occurrence in the JavaScript industry. And the other is get rid of the barred files. So the whole premise here, okay, the whole premise here, or the TLDR of all of this, is to say, hey, if you for okay. Okay, if you find yourself in the need of using a barrel, okay, if you find yourself in a project defining barrel files per component, that might not be quite problematic, but their impact, but there is a there is a model graph construction cost implicit. So, all right, it makes a lot of sense here. So that'll be all for this video. Take care. Bye bye.